Hello everyone, this is my English speaking practice. I'm gonna solve this problem today. Merge k sorted list. You are given an array of k linked lists. Each linked list is sorted in ascending order. Merge all the linked lists into one solid linked list and return it. Okay? That's simple. Is it hard? I think this is medium level. So oh wait, but k is too big. So the idea that comes to my mind first is to keep track of the head of each list and compare them and pick the minimum one and connect it. Okay. Okay. But I see. So I got it. So we have to keep track of head of each list, and it might be 1000, so that's a problem. But we can use the priority queue to get the minimum one. So we push all of head elements into the priority queue and get the minimum one. Yeah, pop it from the priority queue, and yeah, and we can merge it, right? And then we have get another element of the list, so we just push the element to the priority queue. That's so that's ideal solution. So first of all, prepare the priority queue, heap queue, and it's head of all lists, right? And while heap queue, we get element from the heap queue that should have head is like value and index. Yeah, so in order to form the list, from the linked list to as output, we need the value, and in order to identify which list we take the value, so we have to keep track of the index of the value. So this index means which list does contains this value. So we can get the index and identify the linked list. And maybe we just keep track of address, because that's linked list. So yeah, so this must be next address of next node, and we get a node, right? So heap I think we can get the next address means next node, so we can get the value and next address, so we push it to the heap queue, right? So when we I forget, when we pop the node, pop the element from the heap queue, it takes log n time complexity, so and this loop might take O of n, so the time complexity is n log n, and space complexity n, because the heap queue's size would be n, right? N means number of node. So let's code it. Hmm. I forget. Heapify, heap push, heap pop. Right. Okay. So for lists heap so it means this is the head node. So if head, we push head value and head next. This is the initialization, and while is this correct, or the heap queue have the length or size? I think this works. Yeah, as long as heap queue have elements, we are gonna pop from it. Before do that, we need pivot is the list node value, right? Yeah, value is 0. Okay, and heap pop from H. Yeah. Next. We get value and next node, and current cursor. We have keep track of the current node, and that would be Mm? Initialize a new node and current next to be the node, and the current should be node, right? Yeah. And for the next node, heap queue push next node value and next node next, right? If next node exists. And return pivot next. Optional list node. Okay. If let me see the test result. What is it? Instances. Okay, so we cannot use the instance as a element of heap queue. So maybe this should be index. So enumerate lists, and we need to keep track of the index. So give index and address I should be head next, right? And this should be index, and the next node should be address index, right? Because that is the list node, address of list node. So we can get the next node, and if it's not none, we push. Index doesn't change, but address index should be next node address, not address, next. Okay. Heap push. Alright. Okay. Two arguments. I see. My bad. Oh, great. Nicely done. I think this works. 1, 2, 3, 4, 4. Let's submit. Oh, great. Nice. Maybe I used heap queue for the first time in read code. So I want to see the complexity. Oh, this is what is it? It seems different solution. merge list. It seems to take two lists and merge it. And update the lists. Merge list just merges two lists, I think. nlog k. Oh, I see. Merge two. So, okay. Makes sense. So this is nlog k. What is n? This is same nlog k. Because k is the length of lists, so the heap max size of heap q is k, because this loop is k times. So the operation takes log k at the most, and this while loop takes n times at most, because this is needed to be executed for each node. So nlog k, and space complexity is space complexity is k. Because we have address and age, both of them are limited to k, because address have a index as a key, and for age, as I said, it have k lengths at most, right? But this is n. It's because maybe this temporal list should have each list. Oh, but my solution is not good for memory. I think it's because we initialize a new node. So let me change like this. And the node should be retrieved from like this. And the next node should be node next. How about this? Great. And let me see the memory. Memory usage. Okay. It doesn't change. So this solution I see. This solution needs two data structure, two additional data structure to keep track of some information. So this is not memory friendly. Friendly is Japanese English, I think. So relatively this solution use much memory, I think. But it's okay. It's okay. I like this solution, but yeah, divide and conquer is cool solution. Divide and conquer is also cool solution. We can merge first two lists and then push it back. Keep doing this until there is only one list left in vector. Actually, we can regard this as an iterative divide and conquer solution. Makes sense. Okay, but it is interesting. My the time complexity of my solution and the time complexity of the merge solution is the same. Although they are different solution, but the time complexity are the same. So that's interesting. It is interesting. The time complexity are the same, although my solution and the another solution are totally different. It's interesting how my solution and another one take completely different approaches, yet they have the same time complexity. Okay, finish. So today's stream is done. I continue to solve one problem a day, so one hard problem a day, so I will finish this stream. Thank you for watching. Bye.